Everyone, and welcome back. So this time we're going to be going over if, else statements. Now I know it says elif, but it's else if. It's just shortened and stuck together. Now, why do we do this? Well, if you remember our previous example, we had that absolutely horrifying way of writing this. There's all this pain right here, not fun. And we had all those nested if statements, just not good to look at. So what we're going to do to fix this? Well, what we're going to do is we're going to use else if statements. They're going to help us out. So in our else if statements, what we're going to do? Well, we're going to have if, and we're going to have elif, and then finally an else. You don't actually have to have the else if you don't want to, but we'll talk about why you want that. Okay, so what does else if do? Well, if the first if statement fails, it checks the next, else if. And if the second check fails, it goes to the third, else if. Third check fails, it goes into the kind of catch-all case. So in this case, I'm going to enter a temperature. And if the temperature is more than 100, it's going to print out that it will be a gas. If it's not, then it goes down to the next condition. If the temperature is less than 0, and the temperature is more than or equal to negative 273, then that water will be a solid at that temperature. And if it's not between those temperatures, it means it's a liquid, so we go to the next one. And if the temperature is more than 0, water will be a liquid. Because it's not more than 100, and it's more than 0. Okay, now if the temperature doesn't meet any of these qualifications, it means it's too negative. It's probably like negative 274 or something. And there is no water at that temperature. There is no temperature that low. And so we just say that number is too low. So all these things are caught. Each of these is connected. It's very important that they're all connected, because if they weren't connected, then water can be more than 0 and more than 100 at the same time. Both of these could be true, and both of them would print out at the same time. Okay, now let's actually see this in action. Now you do it once, and I'm going to change it to break it. Okay, so I run it. Please enter a temperature between negative 273 and infinity. I'm going to do 999. And I run, water would be a gas at 999 degrees Celsius. It works good. Now I want to get rid of this. Instead of it being an else if statement, I'm going to make it an if statement. Just to show you that they're not the same thing. A bunch of ifs right after each other don't do the same thing. So I run it again. Run. I'm going to do 999 again. And it tells me that water would be a gas at that temperature, and water would be a liquid at that temperature. And as you can see, I forgot to actually fill in my percent here. So that's wrong. I mean, at 990 degrees Celsius, water is most definitely going to be a gas. So there's an issue there. That's why we have to have that else if. It connects each if statement together. Now this catch-all case, the else statement at the end, that is to make sure that we catch everything. So if something doesn't meet any of my previous conditions, then it hits the else statement. It will finally meet that condition. So hopefully that makes sense. And we'll keep on going forward. So I'm going to fix this and change this to an else if statement. Cool? Okay, run it again. 999, fingers crossed. Hit enter. And water would be a gas at 999 degrees Celsius. Fantastic. Okay, so else if makes things more concise when you're typing it out, makes it easier to read, and it connects together all of those if statements, which is a good thing. You want that. Remember, if the first one's true, none of the other ones get seen, which is a good thing, but if for some reason you want the other ones to be seen, they don't need to be connected that way. Okay, lions, tigers, and elephants, oh my. Okay, it's a terrible pun, but still, my 3-year-old laughed, and you should be thankful. Okay, so this is a pretty long little script here for you. We're getting there. You're building up skills as you go. What we're doing is we're building a calculator to help determine what animals can fit in a circus's train. Each train car can have no more than 10 animals and can't hold a weight of more than 60,000 newtons. So we got a little section right here that we need to fix. Everything else is good. We have to fix this section. So we want to update the code so we only check to see if we can add a new animal if the animal's weight would not overload the car, else skip. Okay. That's fine. So if else, well, this is only an if statement right here. So maybe I need to connect them. Else if, there we go. And we're going to increase the total mass by the mass of each animal we add. Okay, so we have a variable here called total mass, and we're going to add mass to that when we add an animal to the train. We have the masses of each of the animals right here. So I can do that pretty easily. Total mass plus equals, and that can be masses, and then whatever the animal is in the range. Let's see. Animal is right here. That's the name of the animal I'm going to input. Animal. Okay. And then we're going to add the type of animal to the animals on train list. Okay, so I've got a list right here of animals on train, and so I'm going to just add this animal, whatever it is, to that list. So animals on train dot append animal. There we go. So that should be enough to make this work. Should all go hunky-dory, and you can see that I was messing around with this a bit earlier. Now, rather than run through it and actually show you that it works, I want to talk about what everything's doing here. So first off, we have masses for each of the animals: lions, tigers, and elephants. I would have done bears, but I wanted something big. Also, I needed an elephant. And I have gravity. Why gravity? Because these are masses, and I said that the max it could take was 60,000 newtons. That's force, that's weight. So mass times gravity is weight. Animals on train is just a fun way of seeing how many animals we have, and also checking to make sure our mass doesn't get too high. And then finally, total mass to check things. So I say for I in range 100. I'm just giving myself way too many loops, because there's no possible way I could have 100 loops. At some point, I'm going to max out this train. And I can't fit 100 tigers on there. I can only fit 10 animals. So technically, I probably should put 10. But I just added in there just in case there's some weird way I need 11 loops. Then it's going to ask me a question. It says, okay, what animal do you want to add? And you type in elephant, lion, or tiger. And then it starts asking some questions of itself. It says, well, if the total mass plus this new animal is going to be more than 60,000 newtons, total mass times gravity is going to be more than 60,000 newtons, that's going to be too heavy. It's like I can't add 10 elephants. That would hit it way too quick. So I need to check before I add the animal. I can't put it on there and you're like, oh, everything collapsed. No, you check beforehand. Okay. And then I use something that's kind of new to you that we haven't learned about. It's called the continue statement. It just jumps to the next loop. So the loop's starting and it skips everything else and just starts the loop again. We want that because that animal doesn't work. We need a different animal. Okay. So else if len animals on train is less than 10. So we have to check here and see, do I have 10 animals on the train? If I've got 10 animals on the train, I can't add another animal. I really shouldn't be in this loop at all. But if I don't, then possibly I can. So if the mass isn't too much, and if I have less than 10 animals on the train, well, then I add the animal. And if that's not the case, if either of those two are false, or sorry, if both of those are false, then it goes to the else statement and says, well, the train must be full because we have more than 10 animals, and it's too heavy if we add another one. So we're good. This if statement right here just checks to see if there are any animals that are actually small enough to get on the train. If there's not, like if a tiger, which is the smallest of these animals, can't fit, nothing else can fit, and so we just need to go ahead and break. And the break statement is a nice thing for for loops. It just ends the for loop. So if you see a break statement, nothing else below that happens, and no more of the loops happen. It just jumps out, pops out. It's really good for having some sort of condition to end your loop if you don't know how long you want it to go. Okay, so with that, we've gone pretty long this time. I apologize for that. But I hope this code makes a little bit more sense. I know it's a lot there, but try it out. Mess around with it some. Mess around with programming. It will help you. It's a good skill to have. If you enjoyed this, I'll see all of you next time. Bye-bye.